Hey everybody, Dave Lindberg on a cloudy day here in Hong Kong for another episode of THD Podcast. Joining us today from Israel, we're going to have a company called Kardome. They're going to tell us about their speech intelligibility software. They're doing some clever things, working with noise reduction and stuff so everybody could hear, focus on the person, focus on the listener. So that's kind of the topic of today. But without delay, let's not forget about our sponsor, the ALTI Association Audio Loudspeaker International. And so they're having a show coming up in Vegas, June 5th and 6th. It's kind of on the end or beginning of Infocom. So a lot going on in the audio industry in Vegas that first week of June. So be sure to check that out. But without delay, let's say hello. Simon in Japan this afternoon. How are you doing today, Simon?
Good day, good evening, and morning, Dani, I guess.
All right.
Good morning.
Yeah, so Dani Cherkassky, the CEO of Kardome, coming to us from Israel. Thanks for joining us today, Dani.
Thank you for inviting me.
Yeah, so we discovered your technology. I think you guys have a partnership with Knowles, if I'm not mistaken.
Yeah, Knowles is indeed one of our dear partners.
Yeah, so they're kind of a celebrity when it comes to microphone pickup around the world. So a very, very strong partner. And so we discovered you and we read up on you, and you guys sound like you're doing some fascinating stuff with this voice intelligibility category, like making clarity to the pickup. A lot of people have probably experienced either noisy environments or such where they can't hear the caller or can't hear the person on the other end. And so you guys are venturing to solve that issue. So can you tell us about the company and how the technology works, please?
As you mentioned, we are Kardome, and we try to enable machines to listen and to understand speech the way humans do today. And I mean, when starting Kardome, we ask ourselves whether it is reasonable that in a few years from today, you will be able to step into such a robot taxi in the middle of a big metropolis and get a keyboard in order to type in your destination. Mm-hmm. Or with other devices, whether it's going to be reasonable that you're going to wear a state-of-the-art AR glasses, but you will control your applications with knobs and buttons. And the answer was no. Mm-hmm. It's clear that you will have to speak to those devices because this is how humans interact with each other, basically. This is the most efficient, the more effective way for humans to interact. This is how we interact with other humans. And actually, this is, to a certain extent, this is how we are starting to interact with machines more and more today, but it is still not there. Mm-hmm. I mean, from one perspective, the voice market is huge and it is rapidly growing. From the other perspective, if you look on what is it that you really do by voice, generally speaking, search, navigation, and streaming. Those are the three basic things or the three things that people are doing by voice on a daily basis and with a significant engagement level, I would say. Mm-hmm. When it comes to operating computers, machines, devices, either in-home, in our cars, while shopping in malls, we are still stick to touch and buttons and knobs. We are not doing it by voice. And through our journey in Kardome, we actually asked leading manufacturers, what is it that is missing? Why you are not using voice in order to facilitate for your customers to control your devices? And it's not an academic study, but it's not very far from that. Here are the key findings. All believe that HMI in general and voice in particular are important puzzle pieces towards their product. All are also believe that one day voice will take over all other interaction methods. But the key missing points or the key points where the technology today is falling short are accuracy, cost, speed of interaction, and privacy. Mm-hmm. And the second thing is that basically there is no single solution today in the market that address all the above mentioned pain points. If you are a manufacturer of voice-enabled devices and you want to buy an holistic end-to-end software, the plug-and-play software that will replace buttons or any other interface that you have in your device and enable your customers to control it by voice, you have almost no one to buy it from.
Mm-hmm.
And if you are going to buy puzzle pieces and put them together and end up with building your voice user interface stack, putting in your devices, here is the results. This is the accuracy of the state-of-the-art systems today, as was measured. Again, this is a car example. It was measured by Head Acoustics, a well-recognized lab for automotive measurements. And what you see here is the speech recognition rate in different scenarios. So the car is driving, and you can see that even in the simplest scenario, the speech recognition is about 50%, and it goes down when the scenario becomes more and more complicated. And actually, I have a very, I'd say, not from one point nice, from the other point disappointing experience with those systems in cars. I was traveling in Germany a few weeks back, and I got a state-of-the-art Audi rental car with really top, I believe it's top-in-class voice user interface systems implemented there, maybe comparable only to Tesla. And you could actually control the car by voice. I mean, the funny thing was that I said, hey Audi, turn on the air conditioner, and it's really turned on. But from that point on, you couldn't control the car by voice anymore. The noise of the air conditioner took over the ability of the car to understand speech.
So that was the noise floor creating that interference level, and it couldn't pick up your voice after that.
Absolutely.
Right.
Absolutely. And you know why? You know how those guys are solving those challenges today? Here is how. They provide a manual that puts the responsibility on the user to create an environment for the system to work. Avoid background noise, make sure the windows are closed, ask your passenger not to speak. So you know what? At some point, I believe this is what turns those systems into a gadget rather than being a reliable interface. And I believe this is something that we need to solve if we want voice to break this glass ceiling of being a gadget only.
Right.
And here we are coming it's very much connected to how you started presenting Kardome. We identified two main challenges today that preventing from voice taking over buttons, if you wish. And the first challenge is related to those environment. We call it an auditory scene analysis, but it's very much related to those noise reductions and ability to separate speech that you mentioned. Now, if I take you or any other human being, I close your eyes, put you in the middle of unknown environment, in fractions of a second, you will be able to build yourself the auditory scene that is around you. There is a speaker over there. There is one over there. I'm in a noisy environment, or I'm in a closed, in a quiet area. And from that point on, some better, some worse, will be able to decide to whom you want to listen. While computers and machines falling completely short in that regard. You put a machine today in any environment, it captures the mixture of speeches or voices or sounds out there. It completely lacks the ability to understand the environment it is located in. And practically, as you mentioned, it has a hard time to distinguish between speech and background noise. And it completely fails in understanding a target speaker in a multi-speakers environment. This is, I believe, the main challenge towards unlocking voice as a reliable interface. The second challenge is actually very much related to how those systems are built today.
Mm-hmm.
So, as I mentioned already, there is no single supplier where you can buy the entire voice stack from. What you can do is buy puzzle pieces as a manufacturer of voice-enabled devices. Buy a piece of puzzle pieces and try to stick them together. And though it puts two limitations, or two, of course, you have the engineering work to be done. You need your experts, your engineering team, have a voice expertise in order to being able to assemble such a puzzle. But it is actually more than that. Even if you have the right expertise in your team, those puzzle pieces, they were developed independently. And once you take two independently developed systems and you try to stick them together, they are not fitting so well. You just glue them together the best way you can, but what you end up really with is this kind of limitation. The systems couldn't understand you in a noisy or in a difficult conditions.
Right.
And this entire thing of voice, if you look on where we've been a few decades ago, when voice was, just first systems were available in the market, it was really a joke, if you wish. You were asking for something for something to happen, and what happened was completely different. And at some point, I believe it was Google guys that came and say, "Hey, the speech recognition engine, here is a neural network. This is how it's supposed to work. This is mimicking the best possible way the human brain, and this is how those systems should be implemented." From that point on, everybody, of course, accepted the idea because it created a big jump in performance. But from that point on, people are saying, "Well, okay, that's the brain, that's the smart system. It will solve all the problems in the world. We will just have to throw more and more data into it, and it will solve it." But let's see what happens. Actually, there are no big improvements in terms of environmental or how those systems can deal with environmental conditions in the recent years. And what we are saying is that no, those systems, those deep neural networks, speech recognition engines, they will not solve all the problems of the world. Why? Because if you try to use them to solve for any environmental conditions, there is infinite number of such conditions that you have to show to the network. And this is why this training process will never end up. And even more than that, if you want to stick to this narrative that Google put in, like this is the human brain, this is how it works, this is how the speech recognition engine should work. So actually, there are two parts to human auditory system: the ears and the brain. And the ears are the one that is responsible for the environmental understanding. And those system comprised of ears and brain was so-called developed and trained together over years. It took us about 18 months till the point that we start to really understand speech. And this is what should happen in a voice user interface domain. What is really required in order to solve this challenge of voice user interface and to facilitate those systems with understanding speech in natural environments is an holistic solution that is comprised of spatial understanding, mimicking the human ears, we call it the 3D audio, and speech AI models that actually were developed together and trained together with the 3D audio and facilitate voice user interface in any environment or almost in any environment, facilitates for us to speak to machines just the way you speak to other humans today. So this system should, again, in order to provide a natural and a reliable interface, the system should be able to provide answers on 3 fundamental questions in every point in time, or in every point when someone speaks to it. Who is the speaker? Where he is located, and what he is saying. And this is the system that we are building in Kardome. and we absolutely believe this is what will enable us to interface with machines using voice.
Okay. And
right.
and-
So the what you might call the traditional system, you just put in one microphone, just pick up whatever noise, and then try to use a neural network to extract some particular number or code out of that. Is that a fair way to categorize the traditional system, like the Google thing that you talked about?
A traditional system, yes, indeed. It was mostly based on single microphones. Manufacturers already moving away from it. It's clear that in order to take those systems to the next step, you need a plurality of microphones, and you need to provide a spatial awareness to the system. And so in that regard, you are entirely correct. And in the regard that this deep neural network thing, yes, the agenda was like, let's show to this network more and more examples with different spatial situations, different noises, different noise levels, and it will solve all the problems in the world. It's pretty much clear today that it will not happen. We need something else that improves the quality of the acquired data for us before we apply speech AI models.
And so when you mention these components, they pay 3D audio, is that referring to like a physical setup, a microphone array to kind of do something in terms of noise reduction or getting a directionality to it?
So yes, we are relying on a microphone array. Or I want to say, I'm not necessarily, microphone array is many times associated, with those big devices with 120 microphones that are able to pick up voice from 100 meters away. This is not what we are building.
Mhm.
But if you look today on a smartphone, the new versions mostly have 3 or 4 microphones. If you look today on smart speakers, most of them have 4 to 8 microphones. If you look today on cars, most of them have 4 to 16 or whatever number of microphones. And the fact that there is a plurality of more than one microphone in the system allows you to be spatially aware. And when I say spatially aware, it includes this simple thing that you mentioned, noise reduction, because basically noise reduction, simple noise reduction, like if there is some background noise, you can do it up to a certain extent, even with a single microphone. But it's not just about reducing the noise. It's really about making the system aware of the acoustical scene that is in front of her. So yes, background noise should be removed or at least reduced. The system should know how many speakers there are in the environment. The system should be able to address each of the speakers, even if they speak simultaneously, up to a certain number of speakers, let's say 2 or 3. More than that, it becomes really, really a mess. Even humans cannot do it. And yeah, the system should be able to decide which of the speakers it needs to address, or which of the speakers should be addressed.
And so the technology that Kardome is developing is software, or it's the physical component and the software?
It's absolutely a software. So actually, in your previous question, you mentioned about providing a system with directivity. And directivity is a term that is very common in the industry, and it's used because many of those systems are using what we call beamformers. Beamformer is about taking an array of microphones, arranging it in a very careful physical setup, and then being able to distinguish between a speech that is impinging from this direction and a speech that is impinging from this direction, for example. Now, there are 2 limitations to this method. One, you are very very restrict, and it's a big issue to locate the microphones physically in a physical setup that will meet your requirements. Second, actually, this approach of distinguishing sources based on their direction of arrival is falling apart in a closed environment. What I mean is that in a room, in a car, in any closed environment, my voice is not traveling from my lips towards the microphones only through the line of sight. It hits all the reflective panels in the environment, which are bouncing the signal back to the microphones. So practically, every speaker, every sound source in a closed environment is perceived by the microphones from hundreds of directions. So if you take a directional based system and you try to distinguish between a speaker that is located in 45 degrees and a speaker that is located from 90 degrees from the system, it's a mission impossible. It's like putting a human being in a hall of mirrors. You will see every possible object from every possible direction. So our approach is addressing those two challenges. First, the solution is software only, and it can work with any configuration of microphones. We are not putting any constraints of the designers on how to locate the microphones on their devices. Second, we are not distinguishing between the sources based on their direction of arrival, but rather we are distinguishing between sound sources that were generated in different spots in place. So instead of being a directional, we are a location driven. We are distinguishing between a sound source that was generated here and a sound source that was generated here, even if they are on the same line of sight.
All right.
Then in your third box, what our speakers saying ASR. Is there actually there's like two approaches to that? One is the Alexa type approach where you capture this audio sequence, you send it off to the server to figure out what the words are and then understand those words. Then there's another approach where you have just keywords or trigger words where there's no relevance what the meaning is. It's just a match or not a match. Are you doing one of those types of things with this part of the system?
The answer is yes. I think that if you look from the high perspective, the two approaches are natural language understanding versus a limited vocabulary approach. And what we are saying is that, yes, this natural language understanding, in order to come up with a great solution to that, you will need those Google and Amazon devices and a cloud-based solution out there because, again, the number of words is infinite. But when it comes to controlling your devices, your cars, your TV, how many intentions you may have? There are 50 intentions. You want to take it to the very extreme. There are 200 intentions that you may, 200 requests that you may need. By the end of the day, this vocabulary that you will use for your TV or for your car or for a self-service machine in a hotel is very, very limited. And on one hand, on the other hand, you expect delayless interaction and private interaction, and to be very robust, like to work in all conditions. And therefore, we address this segment of what you say limited vocabulary solutions that are implemented directly on the edge devices, do not require any uplink connectivity to up and down, actually link connectivity for with the cloud, and we'll be able to service you delaylessly and robustly and privately.
Okay, so yeah, we could just in simple terms, you could say it's working off keywords essentially, and there's no cloud connection required. It's all local.
Well, it's not on when you say keywords. It's pretty much remind to most of us this limited vocabulary menus that we had 10 or 15 years ago with 4 keywords that it could understand. Mm-hmm. The technology today is such that even if you want to train your machine to understand 50 sentences, you can do it on the edge.
Right.
And those,
sorry, Simon.
One more thing, if you don't mind, Dave. So those components, they're actually quite totally distinct fields of science and engineering, are they not? So you've got one that's just heavily theoretical acoustics, something else which is, speech recognition. It's a totally different thing. How do you kind of combine all of those elements?
So I think you are right and wrong. And I will explain. There is a deep belief in the industry that what you just mentioned is a complete truth. Those are completely two different systems. They can be designed and built separately, and then you just glue them together. But what we believe, and actually it's not a belief, we tested it. When you design it in this disjoint way, like you do the acoustical thing on one hand, completely separately. You train your speech AI models on the other hand, completely separate from the acoustical models, and you glue them together. You lose a lot of performance. Why? Because an holistic solution should be architected and designed holistically, and this is what we are doing. Yes, we have our acoustic experts, we have our voice AI experts that working together and putting together a system that is able to mimic the human auditory system, like the ears and the brain that are working for most of us perfectly together.
All right. So, and then in terms of like the arrangement of the business supply chain here, are you guys partnering with a lot of like edge computing chip companies and also even cloud connectivity? I mean, giving that benefit of privacy to cloud connected is a big feature, but also giving the ability of recognition on the edge is another feature. So there's kind of two types of hardware categories that you would be partnering with. Is that a good understanding?
Yes, it is. Our main customers and partners indeed can be split into two. Those chip makers, as you mentioned, are as nodes. They are dear partner for us that actually facilitate for us a go-to-market. So and we facilitate for them, enlarging or broadening the capabilities of their chips. The other kind of partner and customer for us is OEMs, devices builders, whether it's a smart speaker or a car. Those guys already decided on a chip, already decided on their hardware architecture, and they are coming to us and say, hey, how can you support? How can you make our systems, understand our customers in any environment? And for them, we provide our solution, and here is an example of our solution being embedded in a smart speaker. And our customers are actually measuring two main parameters. They're measuring what's called wake-word false rejection rate, meaning how many times you actually try to activate the device by voice and it was failed, and response of accuracy rate, meaning how much you've been asking for something and it's really happened, the right thing happened. And you can see, and of course, those two parameters, they are evaluated in a different SNR conditions. SNR stands for noise, how noisy is the environment. So low SNR is very, very noisy, and high SNR is very, very quiet. And you can see here the benefit of using Kardome. Those are actual measurements that were done by one of our customers, that with Kardome, for example, we can we can provide already, you mentioned, Simon, you mentioned earlier wake-word recognition. So with Kardome, we can provide over 90% of wake-word recognition when the SNR is minus 20 dB. Minus 20 dB is very noisy environment, while typical systems can do today in the same conditions will provide you only with 30%. Same holds for the response of accuracy.
minus negative SNR means the noise is louder than the signal?
Yeah, the noise is louder than signal. So imagine that you are in a shopping mall. There is a lot of bunch of noise around you, and you want to interact with the device. You say, hey, I want a double back royale. So in this scenario, many times the noise is louder than a signal. Actually, even in cars, if you don't restrict yourself to the voice manual and you open the windows, the noise will be louder than a signal.
Yeah, that's actually just on a commercial level. That's a huge issue for the deployment of voice edge devices for things like TWS, true wireless stereo devices. Is a lot of the manufacturers over here, obviously, they're using metros in Hong Kong or in Shenzhen, et cetera. And that's kind of their reference point as engineers is, can we use it in this environment? Well, until perhaps now, it wasn't really possible to deploy. So yeah, I can see the commercial appeal here largely.
Yeah, you're completely right. And actually those applications in metro and such, they are gaining interest now, maybe up to a certain degree in the view of the global pandemic. No one wants to touch anything. And these applications of touch in a metro, we've been asked about it over and over again. And we indeed testing our systems in such applications as well.
Yeah. And yeah, commercial applications like kiosk machines, is that something I think you mentioned earlier that you're approaching as well?
Absolutely. Actually, we have few beta sites where manufacturers are testing our solutions for kiosks.
Mm-hmm. Okay.
Just quickly, what's required in terms of processing power? Would these have to be kind of mains powered or car powered devices? Battery powered devices a possibility?
Yeah, absolutely. We are not requiring any server level processing power. I would say standard CPU that may cost today, I don't know, up to $1 or something in that range will be more than enough for running our systems. Maybe I show you an example of how it looks like when we are facilitating voice interactions in a car. It's actually an integration that we did.
Hey car, start the engine.
Hey car, start engine.
היי, מה קורה?
Hey
כן, אין
car,
שום בעיה.
open all the windows.
בסדר גמור, אין בעיה.
Hey car, I'm cold.
Hey car, close the window.
Hey car, turn on the radio.
Hey car, switch channel please.
Hey car, volume up.
So that was an example of how you could control. I mean, how it would work if any device could understand who are the speakers, where they are located, and what they are saying. And again, as you saw, this position or localization thing is, we believe that it's absolutely critical in order to provide a natural and welcoming experience, if you wish. So if it stays back like, hey car, turn or open rear right window, it's too complicated. The system, you should say open the window. The system should know where are you located and respond accordingly. And if a passenger, for example, is asking to turn on the engine, the system should know that it's not the driver that is speaking and should refuse this command. So this thing of spatial awareness is a key.
Yeah, and if you could get the accuracy high enough with the control feature, I mean, this could be a unicorn type company if you could get that for mission critical type voice control. I mean, that's something that's, they're not really allowing for, car control yet, but you can see if the accuracy could be there, it could be something that would be approved for use. So that's exciting stuff.
Absolutely, this is where we are heading. Our mission is very clear. We want to facilitate voice for any applications out there.
Okay, and then so globally, you guys, I know there's headquarters in Israel, but I think you guys have offices elsewhere around the world.
The headquarter and the R&D is indeed in Israel.
Mm-hmm.
We have an office. A front office in the Bay Area in US.
Mm-hmm.
We have an office in China, in Shanghai, and we have a representative in Japan and a representative in Korea.
Okay. All
Actually,
right.
there is in Korea. There is also a big hardware manufacturer that we are partnering with and facilitating for us this market, this Korean market.
Okay, sounds a little bit very automotive centric with the Shanghai over Shenzhen for China. Is that a good assumption?
Well, yeah. Now when I think about it, but it was not the reason. I mean,
okay. All right. Very good. Simon, do you have any more questions?
I think I've covered it.
Okay. All right. So anybody else that has questions that's watching today, just jot them down below. We'll make sure that they get along to the Kardome team to feedback. And thanks everybody for watching today. Thank you, Dani, for joining us.
Thank you very much for having me here.
All right. So everybody, please like, subscribe, all that good YouTube stuff. Notification bell. Somebody told me that's a big thing. So please do that. And we'll talk to you guys next time. Thanks for watching.